Okay, so I think we can start. Thank you everyone for joining the webinar. And let's see, I have a problem with my camera. 1 second. It's blurring from time to time. So yeah, my name is Uri Maoz. I'm the CEO and co-founder of WireMock. I will soon introduce, we'll let the other, like Tom and Senthil, to introduce themselves. I just want to set the ground, like the agenda for the webinar. So basically, what we are going to talk about today is around the fact that software development practices has changed a lot since most of the SV tools were launched. And we ourselves in WireMock, we speak with a lot of customers these days and prospects that are coming to us and saying that they want to modernize their stack, they want to move to a modern SV solution and migrate from their legacy service virtualization solutions. And we wanted to have a discussion about why now, what has changed, what are these changes in the software development lifecycle that are impacting this momentum of customers that are coming and asking to migrate. So we'll talk about what are the changes, what are the challenges with the SV tools that are not optimized maybe for today's challenges. How does a modern solution look like? And then Tom will also show like a short demo of WireMock Cloud, just illustrating some of the aspects that we were talking about. We will be talking about around the modernization of service virtualization. And with that, I will let Senthil introduce himself, and thank you for joining. And then Tom, and we'll start.
Sure, Uri. Thank you. Thanks for having me. Hello, everyone, and greetings to all of you joining from different time zone, different parts of the world. I am Senthil Manohar Shanmughasundaram, and I'm based out of Toronto, Canada. And I've been working in the space of service virtualization for maybe close to a decade now, having experiences with various industries like airlines, health insurance, financial services, transportation and logistic, telecom, etc. Right? It's a very, I'm very happy. It's a real pleasure to be here with the WireMock team today. I know WireMock team for a long time now. And today, I think we're going to explore how AI and modern simulation are reshaping the way that we test and deliver software. I've seen the evolution of virtualization tool from the like an on-prem solution to cloud native, and now we are stepping into a new era of fascinating new chapter called AI-driven simulation. I'm looking forward to share my experiences as well, and also learn something new from you folks as well. Thank you. Thanks for having me.
Thank you, Senthil. And Tom, a short introduction of yourself.
Sure. So I'm Tom Akers. I'm the CTO and co-founder of WireMock. I also created the WireMock open source project that underpins the product, and so I've been kind of working in and around this space, both as kind of a consumer of the technology, someone who had the sort of service virtualization shaped problems to solve, and also a producer of the technology to solve those problems.
Cool. So by the way, if anyone has any questions, feel free to post them in the chat, and we will answer them as we go. So great. So like I said, we'll have a bit of conversation about the service virtualization, the challenges, and a modern solution. Senthil, maybe let's start with you. Maybe, before we start talking about the challenges of service virtualization, maybe you can talk about what is service virtualization. I'm sure everyone on the call are familiar, but in high level, how do you see service virtualization? What are the use cases that you usually use service virtualization for? And we'll go from that.
Sure. Yeah, that's a great question to kick things off, right? I'll keep it short, right? Service virtualization, or SV, it's about simulating the behavior of a dependent system, and a dependent system can be anything like a third-party API, a legacy service, databases, and whatnot, right? those systems, whenever they are unavailable or unstable, or sometimes it's proving costly to kind of have it in your test environment during your development and testing, SV could actually support in simulating their behaviors. So that's SV. And I would say it can simulate complex behaviors, end-to-end scenarios, basically orchestrate scenarios which is not feasible to kind of simulate, or not feasible to do it in the real test environments and things. Data-driven responses. You can do performance characteristic simulations as well. You can always simulate error conditions also. So these are the basic things about SV. And I would say usually whenever I talk to the consumers who are fairly new, or who are very much interested in implementing SV for their development projects, I would use an analogy of more like a flight simulator. Like if you want to get trained as a fighter pilot in F-16, it's going to prove you costly and the margin of error is going to be high and all that. But rather, if you do it in a simulator to start with, and then you cover all possible scenarios, all edge cases, all negative scenarios, and all those things before you actually fly F-16. So that's the analogy that I use very often. So that's about a high-level view of what service virtualization is all about.
Actually, a good analogy. I might adopt it. So great. And by the way, like maybe a question we also have, for both Tom and Sentinel. So we have service virtualization, we have API mocking. How do you kind of see the differences between them? Is there a difference, and how do you see the difference?
So in my view, API mocking is again a subset of SV. Is what I would say. It's lightweight, focused on specific scenarios or mimicking specific API responses. Yes, SV is something that goes a bit deeper, which would be useful in complex environments, like orchestrating things where you need to plug in few pieces together to achieve an end result. So that's where SV could come in handy. And mocking probably is more of a canned sort of a response. SV could be slightly bit more intelligent. It can be as much realistic, close to realistic as much as possible.
Yeah. Okay, cool. Tom, anything to add?
So yeah, I give us a slightly different answer to that, I think, which is that I think conceptually they're very similar ideas. But I think they have different connotations in terms of how you achieve those ends. I mean, I agree that API mocking tends to imply simple, static, sort of canned responses, whereas SV tends to kind of imply more sophisticated simulations of the thing that you're building, and I think there's kind of a spectrum in between. They're not 2 points. There's a sort of spectrum of complexity, simplicity to complexity from one to the other. But also, I'd say that I think service virtualization also implies a set of. I mean, this is kind of what this whole webinar is about, really, but kind of a set of practices and design choices and so on like that in terms of how you deliver these things. And I think API mocking is about a different set of design choices about how you achieve this end. And in particular, I think the names kind of reflect the software movements that they came from. I mean, I think mocking is a concept that was born in the agile and sort of DevOps early era, and a lot of the design choices in API mocking tools are, arguably kind of reflect, they're being sort of created in that period.
Yeah, great. And maybe, we're talking about use cases for service virtualization, simulation in general, and like Sentinel mentioned, there are various use cases. You want to simulate third-party APIs that maybe they are not available to access from your environment, or maybe you're getting a sandbox that is very fragile and it's very hard to work with and not enable you to do like advanced scenarios like negative testing, load test, and so on. One other use case is about parallel development and how you enable parallel development when API is not even ready. And we can, maybe Tom, you can talk a bit, and Sentinel as well, about this use case, because there is a question that was asked about can you share a real-world example of how a team used tools like WireMock to enable true parallel development and testing? between front-end and back-end teams before the real API even built. Okay, so maybe we can talk a bit about this use case, about the parallel development, and then move to the next questions.
So I can start with that if you like. I had a bit of I learned something new the other day talking to a member of our team who used to work for ITCO, who were the company that made what became CA Lisa and eventually Broadcom DevTest. And he was saying that sort of originally that was a tool that was sold exclusively to QA teams. Basically, it was QA managers who wanted it and their team that got value from it. And what that meant was that the virtual assets you were building were simulations of things that already existed. That were difficult, had all of those difficulties we talked about in terms of their use, but they already existed. What it wasn't was the developer tool. Whereas what we've seen now is the teams tend to be a lot more cross-functional. The lines between kind of dev and QA and so on like that are much more blurry. There's closer collaboration between those roles, even when they're separate. And part of what that sort of implies is that one thing it enables is the ability to prototype things. So if an API doesn't exist, but a particular app or service or whatever is going to need that API, then you can use these tools to build a prototype of those things, to start building the code that's calling it. And to be able to make progress and to validate the design by doing that. And I think this is something that's at least according to to the conversation I had with my team member the other day, that this is something that shifted in the way we deliver software and shifted in terms of the requirements of today's service virtualization tools versus the original generation.
Cool. Senthil, anything to add to that in terms of the use case of parallel development and using simulation in order to enable parallel development between front-end teams and back-end teams?
Yeah, sure. Yeah, Tom has pretty much covered almost everything, but I'll just add maybe a couple of real world use cases that I've seen with few customers. So I worked with a customer where there was a brand new mobile development happening. They had a very intuitive UI, web-based ones, but they wanted to do it in a mobile app. And when they built the mobile app, they had a backend for front-end sort of a layer, which would call the microservices and then fetch in data and then display it in the mobile app, right? But the backend for front-end was a very new concept for the organization itself. They were not able to figure out the infrastructure and things like that. And it took a lot of time to kind of come up with the content for the backend to front-end development. So if I'm not wrong, it was about 16 to 17 iterations. The mobile app development, basically the front-end development, was completely relied on the virtualized APIs or mocked APIs, where we read the contract from the backend for frontend. While the backend for frontend is still being developed, we were able to kind of virtualize those BFFs and the APIs underneath that to provide data to the scenarios that the mobile user wanted to use. So around 16 iterations, they were able to use it. It covered about 5 to 6 months, I would say 5 months. So that's the time advantage that we got in the development phase. This is a pure example of like parallel development when you don't have a deployment system that is not even built. So the initial testing, the integrated testing that they did was directly on a fit environment, like a functional integration test environment, while during the development and QA, they were all relying on the virtualized APIs. I can go on with a lot of use cases like this, but this is something that right in front of your eyes, you see an advantage of about like 5-6 months of like parallel development there.
Yeah, great example.
So yeah, I mean, we can. So just to add to that as well, just to provide another real world example. I mean, we have many of them as well. We have a lot of customers for whom this is the what they see as the sort of primary advantage of the product. But I think it was actually our very first ever paying customer when we first got started. Came with this problem. They were a sort of e-commerce platform, and so had a diversity of mobile apps and web apps and various sort of consumers of their APIs, and they had this problem that they were building new features which required new APIs, and then those front end teams or those consuming teams were kind of having to sit on their hands while they waited for back end teams to ship the design. And then the design process kind of produced, ambiguity sometimes, so they'd go and typically kind of write things on a whiteboard in a co-design session. The back-end team would go away and build the API. The front-end teams would eventually get their hands on it when something was shipped, and they'd go, oh, hang on, this isn't what I thought I was going to get. I thought it was going to be like this. And because the output of the conversation, the design conversation, had been kind of a sketch on a whiteboard, the results weren't great. But then they switched to using WireMock as a collaboration tool, essentially. So they would build a mock as they were having their design conversation in these sessions, and then they would leave the session with something that was kind of a lot less ambiguous in terms of how the API should work, and also kind of a working API endpoint that front-end teams could go and integrate with. And it meant, obviously, the parallelization opportunity for the work, which they claimed on average saved them about 3 weeks of lead time per feature that they shipped, but also gave this opportunity for early feedback. So because you have the mock available to you straight away, and you can start building against it, you can go, oh, hang on, this is not what we expected, but on kind of day 1 or day 2 of the sprint, rather than day 13.
Exactly. So shifting gears, you want to add something, Senthil?
Yeah, just a quick thing that I want to add there is, so when I started on the service virtualization space, it was more about like using it for regression testing, or some setting up some test data and things like that. But more and more nowadays, it's all pushed towards the left, where you start with the development itself. And that's where you're gaining a lot of tractions in SV nowadays, and especially in the API modernization, or like front-end modernization with new CRM tools like a Salesforce and things. That's where the use case of parallel development has taken more traction compared to it used to be before.
Yeah, good. So talking about a bit about the previous, or what we call legacy SV tools. When you go Senthil, to larger enterprises, okay, and you need to implement now a legacy SV tool or operate it, what does the typical setup look like, and how complex or fragmented are those environments? What is kind of your experience running these platforms? Whatever you can share around that would be great.
Sure. So I'll share it in like 2 ways. Maybe I'll keep it short. So I worked with enterprises where the infrastructure was already there, and we had to go and use that as well. And I worked with enterprises where I had to go in and set up the infrastructure right from the scratch. So with legacy tools and legacy SV, like whatever tools that is available in the market, it's more about the infrastructure itself is it needs expertise to handle the tools right there in the infrastructure, right? So they may have a centralized server handling the licenses and other components that revolves around those licenses and the tools. And the setup would be like, we might have to build a small COE team which would actually manage the infrastructure, plus they develop the virtualized APIs or the mocked APIs or the mock services using that tool, right? It would involve a lot of customization and things like that. That's why you may need to have a specialized skills or specialized teams to kind of handle those particular setup. So I would say larger enterprises, whenever they use like legacy tools, so there will be like more about operational side challenges which need to be maintained at the infrastructure level, as well as skill level also. To develop and deploy a mock service, you would need specialized skills.
Okay, so you are saying like basically the outcome of the fact that the tools will be more complex is that you will have a central team that is creating the virtualized services for the entire organization. So I assume, and correct me if I'm wrong, that the workflow is that I am maybe a backend team or front-end team, and I need now to create a virtualized service. Then I'm submitting a request somewhere that it's routed to your team that is doing the creation of the virtualized service, and then you have some backlog of requests that you need to fulfill. This is how it works?
That's exactly right. Yeah, that's how established team, that's how it works. And if the structure is all like resolved and trained and tested. So this works well for a longer time. But in some enterprises, probably the vision might sometimes miss, and you will not create this entire streamlined structure. And that's where it becomes a bottleneck, where the team just take their hands away and say, no, I had to go through all these process and I couldn't use the SP and all that.
Yeah, so it's kind of similar to what we mentioned about the parallel development. It's kind of create like another bottleneck challenge.
That's right. Yeah, that's correct. Yeah.
Now they are waiting for you to create the simulated service versus waiting for the real API. And what did you kind of feel about like you said, how it impacts the adoption in organization and the use of service virtualization because of this challenge?
Sorry, I missed your question. What is it?
Oh, my question is like, how do you feel like it impacted adoption of service virtualization practices in such organization that is this dependency on the central team?
Yeah, so basically that particular the step in between having a virtualized service right in front of your hand versus reaching out to different teams and getting the virtualized services to you, that proves as a hindrance for many of the teams, unless if it is ingrained in the process of the development itself. Otherwise, it has seen a lot of bottlenecks when we actually receive those requests and then respond to those requests. It actually brings in a delay, right? The developers wants something within their control, and they can develop or deploy something from their own local machine or local infrastructure, where they do not have to rely on the centralized team. That's where they would probably need. But yeah, that actually brings a bit of a hindrance to the adoption itself.
Okay, and like also I'm curious, like how much let's say someone submit a request, like how much like in general, like how much customization or scripting do you need to usually do with legacy SV tools in order to stay in sync with evolving API and systems? Like how does it look like the creation of the actual virtualized service for you that is operating it?
I would say it depends on the skills of the developer who uses the SP, because sometimes the tool will have a lot of features, and unless the developer knows that that feature exists, he will be resorting to a scripting and leading to maintenance overhead and things like that, right? So especially in the cases of evolving APIs, every time the API version changes, or if there's a new spec or a contract that changes, there is no mechanism to adapt towards the script or towards the changing APIs automatically, fixing the virtual APIs that's been built already. So it has to be a manual intervention so far. And there is no plugins or things that are available, as far as I know, to kind of read through the evolving contract changes and then adapt the virtual services that are currently deployed in our infrastructure. So definitely, to achieve that level of like adoption, we may need to have scripting involved there, which would handle those changes and then kind of accommodate the existing virtual services deployed on the infrastructure.
Yeah. Okay. Interesting. And
if I could just make sort of there's an observation I wanted to make, sort of mainly about the previous point regarding sort of having centralized teams who are responsible for setting this stuff up and building the simulations. Sort of expanding on this idea that shifts have taken place in the way we build software kind of since a lot of these tools were originally developed. I think one of the key things that's happened, and you see this particularly nowadays with the kind of creation of platform engineering teams and so on, is that there's been a move from away from having kind of specialists and specialist teams that are doing things in general, and a move to enabling cross-functional sort of teams to self-serve. So, rather than having another team who kind of does all your deployment for you and all your build management for you and all of that kind of stuff, you get given a set of tools and templates and conventions and guardrails and so on, and then you can do it yourself. And you get given controlled access to a platform. And I think this has been a necessary shift, because there's whereas a decade or more ago it was common to only release your software once a quarter or once every half a year or something like that. Whereas now we routinely do multiple releases a day. That's kind of table stakes for being competitive. And whereas irregular releases are, you can build a software delivery process around irregular releases, which is sort of tolerant of there being handoffs between different teams of specialists. I think and if you want to do multiple releases a day, you kind of have to shift to this model of people being able to self-serve. So I feel like this is one of the sort of key distinctions in terms of the way this tool space is evolving to support the evolving SDLC landscape.
And Tom, if we generalize this kind of topic that you talked about, so we were talking about companies want to move from a legacy to modern practices. So what are the characteristics that you would consider for a platform to be modern SV solutions? Okay, so one thing is the democratization of the virtualization and enabling anyone to create simulations, but what are the other stuff that you would look at?
Yeah, I mean, like you say, there needs to be low friction for maybe occasional users or non-expert users to be able to get something done with a particular tool, rather than requiring a lot of prior learning before you can get started. I think there's another key thing. I mean, another necessary shift which has happened in order to support these kind of high release cadences we have now is automation and modern software configuration management. So being able to script things on one hand, being able to get things done in code rather than manually or via some non-repeatable route. And then also being able to version control artifacts. I mean, that's primarily the thing, right? Is being able to git manage artifacts, so that you can then have this. You can have a software configuration management system which is kind of based on source controlled assets. That you're able to evolve complex configurations by using this sort of standardized set of tooling around SCM. So I think those are probably the single biggest things. I mean, obviously, as we've mentioned, there's kind of AI now, and integration with AI, particularly AI developer tools, is increasingly a sort of table stake for modern products. I think probably almost goes without saying. I think there's probably a few other minor things that are significant, minor but significant things in this space that are important as well. I mean, it's one of the other shifts that's, I think, happened is whereas the numbers of services involved kind of in the original the original SV generation of SV days, you maybe have tens of them inside an organization or hundreds inside a really, really big organization, but they tended to be big, fairly monolithic services that maybe didn't have that higher rate of change. Whereas now you have very fine-grained microservices. I've spoken to a number of organizations who've got well over 1,000. I think the most I've heard of it so far is 6,000 microservices in one organization, in one platform. And these are all changing. They're all being released multiple times a day. So the rate of change has gone up as well. So I think, again, the frame has really shifted to this, having lots of integration points and lots of change happening in all of those integration points. And I think that's produced a whole new class of problems that maybe didn't really exist or were sort of manageably small back in the early days of this technology.
Okay. Senthil, how do you view it from your end about kind of the characteristic of modern SV platform?
Yeah. So in my view, modern SV solution has to be like a more development centric, right? It has to be easy to use and with intuitive APIs or like with a very minimal setups. And it also has to be a CI/CD native as well, right? So that it integrates seamlessly with a pipeline, as Tom touched upon on the version controlling and things. And it also should be, I would say, cloud ready, scalable is another thing which supports containerization and things. So I would say these are the basic things that I would expect to see in a modern SV solution.
Okay, perfect. So maybe one more question, and then we'll jump to a short 10 minutes demo. So, Senthil, from your experience, what typically will trigger a customer to start a search for a modern SV solution? Is it like the cost, the agility, like the wish to modernize the stack? What are the things that you would say that are kind of the most common, like things that will motivate the customer to search for a new solution?
Yeah, that's a good question. So I would say it's a mix of all. Cost is one of the major factors. Like, I mean, the legacy SV tools are like very expensive. So cost, most of the organization comes down to cost pressure nowadays, and that could be one of the factor. On top of it, as I discussed before, any modern tool needs to be very agile, because team wants to handle it by themselves. They want faster solution instead of relying on a, let's say, COE based teams, which has like very tough customization and things like that. So agility is another factor. And then it should have a adoption. It should be cloud native. It has to be a SaaS offering sort of solution, is what I think. Any customer who is currently in legacy environment or legacy SV tools, when they think of moving on to a modernized SV solution, these are the factors I believe they would think on it.
Yeah, 1 second. Yeah, perfect. So, yeah, Tom, what we wanted so I hope that this was interesting and kind of giving some insights on the challenges that we see today in the market that push customers to modernize their stack and move to a more modernized SV solution, and how a modernized solution look like. We wanted to also show like a short demo that illustrates some of the stuff that we talked about the modern SV solution. Tom, we actually have less than 10 minutes, so I don't know if you can show something in like 7 minutes or so. So we'll just be able to summarize and keep the webinar on time. So I will challenge you.
Yeah, okay. This is a difficult one because I had a whole load of things I wanted to show. Okay, let me dive in and I'll try and cover the very basics. Obviously, you can get in touch with us very easily if you want to see more. We've got a load of more in detail videos on our YouTube channel as well, which you can find easily from our website. But let me dive in very quickly. Okay, so I'm going to draw attention to a few things very quickly. One of which is, so this is WireMock's console. It's on the public internet, and my list of mock APIs also have internet-based URLs. So to the point about kind of making this accessible to to anyone, making it sort of low friction to get on board. You don't have to install anything. You don't have to worry about kind of routing and setup and domain names and SSL certificates and that kind of thing. You can just kind of dive in, create a mock API and get going. So I can dive into one of these. I can configure them fairly easily through this this web-based editor. But it's I probably don't have time to sort of break all this down in detail. There are some things that this has in common with other service virtualization tools in terms of how you configure request response pairs, or stubs as we call them, and there are some differences as well. But the crucial thing is that this is only one way that you have at your disposal to create your mock API definitions. And it's also possible to do it via import of other formats. So there's a whole set of formats, third party and sort of first party, that we support. There's a JSON format. There's a well-documented WireMock JSON format that's shared between the cloud and the open source project. This is a really crucial thing. It's one it's well documented, so you can write it by hand, you can source control it, and it will play nicely with Git and so on like that. You can import and export it sort of in and out of here. So you have the option of working with that as well. And then also you have the option of working directly with code. So this code here will connect to my WireMock cloud instance. So the WireMock open source library it can either run a server locally, or it can connect to a remote server, and it's essentially transparent. And so if I want to configure everything in code, if I want to go given when then, where my given is setting my mock up and then my then is verifying some interaction with it, then I have the option of doing this as well. So what this gives you is it's sort of multiple ways into the same the same solution. If you're maybe a tester who's not sort of super into scripting things, but big on exploratory testing, then you can dive in and edit things within here, and you can get things done, turn things around very quickly. But if you're a developer and you're coming at this from a code-driven point of view, then you have the option of doing this as well. So that's one observation to make. One other thing you can do is so I mentioned sort of automation and scripting, I think, is one part of this sort of modern what is now kind of table stakes. But there's the other part of it is being able to do kind of configuration as code, so sort of source controllable, and a system that you can enroll into your modern kind of software configuration management process. And I what I'll show you very quickly is how you can use. So WireMock has a CLI that allows you to push and pull content in a way that's compatible with Git. So if I very quickly go and grab the ID for this mock API that I'm looking at, I can say WireMock pull mock API this, and all being well, it will give me some success messages, and then I should be able to open up an editor, and you see it's created this .wiremock folder, and it defines my list of services. So we just have one at the moment. I can actually pull multiple services. I can also run them locally from here, by the way. We probably don't have time to get into that now. But as you can see, also, it's given me this nice source controllable YAML definition for all of my services, YAML version of my stub definitions, my open API doc, and so on like that. And I can push in the other direction as well. So if I want to go and replace the configuration of an API, I can push from the CLI. And what this allows me to do is to kind of build up configurations code workflows. I can source control this. I can use pull requests and merging, that kind of thing, in order to sort of control the configuration of an API. I can automate the delivery of configurations to different endpoints through CI/CD and so on like that. So this is pretty important. I did just see a question pop up about recording. The CLI also supports recording, so I can very quickly do my favorite, the GitHub API, and we'll say to, in fact, let's just record it to the same API that we just looked at there. So that should start recording. Okay, it's giving me a recording endpoint at localhost 8000. So if I say curl localhost 8000 users, so users is an endpoint within GitHub. As you can see, it's giving me a load of data. It's picked up that we've hit it there. If I stop the recording and hit refresh, then now we see we've got this user endpoint here. So yes, so that was a simple example of recording using the CLI as a proxy. So this means, if I want to record a private microservice that's not on the internet, that would have worked perfectly well with that as well. The recording in itself is a deep topic. I could have gone into that a lot more, but that's a flavor of how that works. One other thing I want to dive into very briefly as well. One thing which is, as we mentioned, one of the key distinctions, I think, between one of the things that's changed is this desire to do prototyping. I think we both said that there's been a shift in the way people use service virtualization tools towards enabling parallel development and prototyping. So WireMock supports OpenAPI sort of side by side with mocks. OpenAPI itself isn't enough to kind of describe rich mock behavior, but it's great at sort of describing syntax and structure. So we kind of maintain both in parallel, and we can generate in both directions between them as well. And in fact, the nice thing about this is that we get nicely generated documentation for free as we're building something. So maybe as my final demo, and this will also loop in the AI part very quickly as well, is to add a new prototype, a new endpoint. So say I want a cancel a charge using a delete for this API that I'm prototyping here, this sort of simple payments API. I can now, via the WireMock MCP server using Claude Code, I can say add a This is where the AI will completely balk on me and fail, as it always does when I try and do a live demo. But there we go. We'll see. Okay. Seems to be cooperating so far. So if you haven't seen Core Code, it's a probably the most popular, maybe outside of GitHub Copilot, coding tool. It has an MCP support, so it's connected to WireMock's MCP server. And in fact, there we go. So we can see it's added this endpoint here. So it's used the MCP server. It first went and fetched my existing stubs. It had a look at them. It created a new stub and then uploaded it via import. And now you can see we have this documentation page for it. We, in principle, should be able to make a request through the test requester and get a valid response. If we go back into here, then we should also see, yeah, there we go. So we can see the stub that it's created as well. So hopefully that gives you a very sort of quick flavor of how you can use WireMock for prototyping. So this is kind of creating the mock first, but then generating the open API kind of off the back of that. So I can, as I talked about earlier, I can come up with an idea for a new API endpoint. I can prototype something. I can put it out there very quickly. It's available on a live endpoint, so my consuming teams can go and build something against this. They can validate the design, and if it's wrong, then I can change it very easily as well. I can fix the design. I can iterate on it until we get to the right design, and only then do we commit to actually building it for real. We're probably running out of time now, but it's probably worth just pointing out that it is also possible to go in the other direction as well. So I can bring in an existing open API here, and I can generate the stubs from that. So that will implement the behavior that's defined in the open API. And the great thing about this is that can be my starting point. I can generate a bunch of stubs that are valid, but then I can elaborate them. I can enrich the behavior. I can make them data driven. I can make them stateful if I wanted to, and level up the realism of the mock API that I'm building by building on top of that. And if I switch on the validation function, then this will ensure that as I make my enhancements, that I'm staying true to the open API specification, that I'm not drifting from it. And incidentally, this can also help you deal with drift over time. So as like I was saying, APIs change very rapidly in big microservice organizations. It's very hard to keep up. But if you're working with open API and teams producing APIs are using it, then you can, if you keep importing the most up-to-date open API into your mocks and using validation, then this gives you an early warning system to say when your mocks have deviated from your API. This is a really important thing, a really important requirement when you're working with all this stuff at scale.
Thank you, Tom, for the 10 minutes demo. And yeah, that was great. And yeah, so basically, just to summarize, I hope it was educational and interesting to hear about the challenges of today legacy SV tools. And we were talking about like how teams now need more automated tools, configuration as code, the democratization and simplification, and enabling every person to use service virtualization tools, the prototype capabilities, and some more aspects. And this demo was very, very quick. So if you are interested to hear more, then feel free to approach us, and we'll be glad to show an extended demo and answer any further questions. To summarize, we also wanted to do a raffle for AirPod 3. So we'll do it post the call and then send the person that won it the AirPod or how to get it. So yeah, thank you everyone for joining. Something, anything else to summarize the discussion before we wrap up?
Yeah, pretty much. It was a great demo, Tom, and it was great having. Thanks for having me as well. I learned a lot.
Well, thanks for joining us. Yeah, it's been a really interesting conversation.
Yeah, I learned a lot from the WireMock stuff. Though I started with a bit of the standalone WireMock. Now I think it has evolved a lot. I learned a lot. Thanks for having me.
Yeah, thank you very much for joining. Really appreciate that. And thank you everyone for joining the webinar. And again, if there are further questions or if you are interested to see longer demo with a different pace, then feel free to approach us and we'll be glad to set up a time. Thank you very much.
Thank you, folks.
Bye. Bye.
Thanks, everyone. Bye.